Hello students, today we will discuss a new topic and that is unit plane. Firstly, we will see why this topic is important. In the previous lecture, we have discussed the system matrix of a thin lens, of a thick lens, and we have system matrix of thick lens. It is a 2 cross 2 matrix and the elements are 1 minus P2 into T divided by mu. Here P2 is the power of second refracting surface of the thick lens and T is the thickness of the lens and mu is the refractive index. Okay. Then we have minus P1 minus P2 and plus P1 P2 divided by mu and T is the thickness again. And here we have T by mu and here we have 1 minus P1 into T divided by mu. Now in case of thick lens, let me make a thick lens here and discuss with you what are the various parameters and what is the difficulty to find out the power or focal length or thick lens formula in case of thick lens and what is the importance of unit plane. So here we have, in case of thick lens, we have two surfaces S1 and S2 whose radius of curvature is R1 for the first surface and R2 for the second surface, and its power is P1 and the power of second refracting surface is P2, and power and radius of curvature are related by using formula. Power is refractive index of second medium minus refractive index of first medium divided by radius of curvature. So if you write the power of first refracting surface, it will be mu minus 1, as you have seen in the previous lecture. This thick lens is placed in air medium. So here we have air on the both side. Okay, and this glass is of refractive index mu and the thickness of this lens is T here. Okay. So all distances are measured from these two refracting surface. Here we have an object in this plane. The space on the left hand side of first refracting surface S1 is called object space. So this is our object space. In object space we have object plane. Okay, and this is the image space. In image space you will get the image. Okay, and this is the space in which image is formed. So if object is placed in this plane, then its distance, it is denoted by d1. Okay, and the distance of image plane from second refracting surface S2, that is denoted by d2. Okay, now come to unit planes. Unit planes are the two planes, one in the object space, another in the image space, where the lateral magnification is unity. So here these are the planes where lateral magnification is unity. So these are two planes, one is in the object space and image space, where the lateral magnification is found to be unity. So the meaning of this is, we have discussed in previous lectures that the magnification is given by y2 by y1. This is a unitless, dimensionless quantity okay, and this is 1 if the object lie in the unit plane, okay. So this means that you will get y1 and y2 equal. So it means that if this is the unit plane, this is the first unit plane and this is in the object space, and its distance from the refracting surface, this distance is du1, okay. And similarly, and the distance of this object plane, this is object plane, distance of object plane, that is taken here u, okay. So here we are measuring the distances from the unit plane. This is u, this is du1, okay. And here suppose we have image plane, sorry, this is the second unit plane and this is in the image space UPI, and the distance of this is du2, okay. And the distance of image plane, this plane is image plane. So here you can see the image plane and the unit plane in the image space, second unit plane both lie in the image space, okay. And its distance of unit plane in image space is v from the image plane. So here you have image, and the distance of image from second reflecting surface is d2. So from here you can see this total distance d1 is equal to u plus du1, and this distance d2 is, so here class, so d1 will be equal to, here I am writing d1 this is equal to u plus du1. So d1 is u plus du1, okay. Then come to d2 is du2 plus v. So we can write d2, this is v plus du2, okay. Now let us understand what happens in case of a unit plane. So here we are to see the height of the ray with respect to optical axis. This is our optical axis, and if a ray in the unit plane is at a height of y1 here, if this height is y1, then this ray will emerge from this unit plane at the same height, and this is y2, y1 and y2. If y1 and y2 comes out to be same, then the magnification will be unity, okay. And these planes from where the ray of light is passing at the same height with respect to optical axis, then these planes are said unit planes, okay. Now we will apply this condition here, okay, and here also, and this is magnification, and from this matrix, as we have done in the previous lecture of lateral magnification, we have seen that this is equal to 1 by m, and here m is magnification, and here you get minus a, here you get 0, and here you get m. So from here you can see 1 by m, if these two matrices are equal, then their corresponding elements will have to be equal, So class, comparing the elements, you can find the value of magnification from here, okay. So now 1 by m will be equal to this 1 cross 1 element. So I am writing these things here. So here we have the magnification m, this is from this matrix we have b plus we have b plus a d1. Okay, and b plus a d1 inverse. Okay, inverse, or you can write it 1 by b plus a d1. Okay, and then come here, if you compare this 2 cross 2 element, then m must be equal to this. So this will be equal to c minus a d2. Okay, now we are to find a relation between this u and v, which will connect us with this a element of the matrix. Okay, and this will be found to be it will be equal to 1 by f, inverse of the focal length. Okay, and from there you will get the thick lens formula. Okay, so here let me clear this space. If we are to find the position of unit plane, then what you will do, you will substitute, you will make use of this formula. So if magnification is unity, then from here you can see, then if magnification is unity for the unit plane, then the distance of the unit plane have to be equal to du1. Okay, I want to say that if you make this distance d1 equal to du1, then you will get the magnification equal to unity. So you are to do two work here. One is you are to put the value of d1 as du1 and the value of d2 as du2 to get lateral magnification equal to unity. So from here we have put the value of lateral magnification equal to unity. Then this relation will reduce to, you will get 1 by b plus a, and in place of d1 you will write distance of unit plane du1 from the first refracting surface. Okay, and then you have c minus a d2. So here d2, what is d2? d2 is the distance of second unit plane in image space from second refracting surface. So I have to write here du2. Okay, now we will find the value of du1 and du2 so that we can find the relation between d1 and d2, or you can find the relation between u and v, and further the relation between f. Okay, so if you make use of these two first factors, then we can find the value of du1. So from here du1, this will be, you are to rearrange this relation and you will get, it will be 1 minus b by a. Okay, in the same way, if you put this factor equal to unity, then you will get du2, this is equal to c minus 1 divided by a. Now you are to put the value of du1 and du2 in d1 and d2. Let me clear the space. Okay, we have make use of this system matrix, so we can clear this space. Okay, so here we will find the value of d1. d1 is u plus u plus du1, and du1 is 1 minus b by a. Okay, and then d2 is v plus, we have v plus du2 is c minus 1 by a. So in this way you can find the value of d1 and d2. And one more relation which you have obtained in the previous lectures is the relation between d1 and d2. These all relations we have obtained in the previous lecture, where we have found the system matrix for the optical system. Okay, and here the optical system is a thick lens. The relation there we obtained was B. Okay, so B is one of the element of the system matrix. Then we have D2 minus D and plus A, D1, D2, then minus C, D1, and this was equal to 0. And we obtained this relation when we solved the case of axial object, the object placed on the axis. Okay, so now if we make use of this relation and find the relation for D2, then you will get, let me clear the space. So here we will find the relation from here. The relation for D2, this will be equal to, keep D2 on one side and take rest of the factors on another side. So you can take D2 common, then from the first factor you have B, and then you have A D1, okay, and take both negative terms on the right hand side, and you will get D plus C D1, and from here you will get D2, this is D plus C D1 divided by B plus A D1. Okay, so now you are to put the value of D1 and D2, which you have obtained in terms of distances of the unit planes and unit planes with respect to object plane and image plane. V is the distance of unit plane with respect to image plane, and U is the distance of unit plane with respect to object plane. Okay, so basically we have eliminated D1 and D2. Okay, we have converted all relations in terms of U and V. So distances here we are taking with respect to unit planes. So here if you put the value of D2, and this is the value of D2, this is the value of D2. So D2 is this. So put here the value of D1 and D2. D2 is V plus C minus 1 by A, and this is equal to D plus, this is D plus C D1, and D1 is this. Okay, so this is C and D1 is U plus 1 minus B divided by A. Okay, and then we put the value of denominator, and that is here B plus A into the value of D1. This is D1, and U plus 1 minus B divided by A. Okay, so here we will solve this. We will solve all this. So here we have V. We will take this factor on left hand side. Firstly solve this. You have here A, and take LCM of all this factor. Then you will get D into A. You will get, I am writing here AD. Then you will get A into C into U. So I am writing here A, C and U. Okay, and from here you will get C into 1 minus C into B. So I am writing here minus C, plus C minus B C, and this is to be divided by a. You have taken LCM in numerator. Now come to denominator. From here you will get a b plus a square u, okay, and then plus a and minus ab bracket close, and then the LCM is a. So you can see the a will cancel here in numerator and denominator, and you are to take this factor on the right hand side, so it will acquire negative sign here and it will be c minus 1 divided by a. Now you are to take LCM again here, and you will see plus ab and minus ab, these will cancel out, and from here you can see you can take a common. Okay, so here you can write, if you take a common in the denominator, then you can write this will be 1 plus u. Okay, so let me write this factor in place of denominator so that we can use the space effectively. So here we have a 1 plus u. Now what you are to do, you are to take LCM again and solve it further. Okay, so here you see the LCM will be a into 1 plus u, and if you solve it, then you will get this factor will be same. So let me write it first. This is AD, then plus ACU, then plus C and minus BC, and here you will see one A will cancel, and you are to multiply C minus A with 1 plus u, and negative sign is here. So firstly, if you multiply C with it 1, that is minus C you will get, and then you will get plus 1, okay, sign will change, and multiply u with C minus A here, and here you will get minus cu, and then plus u, okay. So this is the thing. करेंगे, रुक जाए एक मिनट. So class, here we have made a mistake. You see, if you take LCM here, then you will get a term that is a square into u, and if you take a common, then a is left with u. So here you are to write au in place of u. Okay, so we have to correct it. It is au. Okay, now see what happened here. You see that C plus C and minus C, these will cancel. Okay, and then you have rest of the factors will remain the same, and now we will solve it. We will make use of determinant of. Okay class, so further we have to multiply this with numerator also. So let me do it again. So here you see the LCM is a into 1 plus au, and this numerator will be same, that is AD plus ACU plus C minus BC, and then you see you will multiply C minus A with 1 plus AU and consider the negative sign, and here you will see it will be minus C minus plus 1, and then AU with C, it will be minus ACU minus plus AU. Okay, so this will be the part of a numerator. Now we see which factors will cancel here. So you see plus C is here, minus C is here, these will cancel out, and ACU this is positive, this is negative, so these will also cancel here. So now we will see that this is AD and this is BC. If we take -1 common from these two terms, then you will get plus BC and it will become negative minus AD. You see, you have taken minus common in these two factors, and here you have +1, then you have plus AU. Okay. So here we will make use of determinant of matrix now. Write the denominator. It is A into A plus A1 plus AU, and this is our system matrix. If we find determinant in term of ABCD, then BC minus AD, it must be equal to unity, and you will put the value of this here, and it will be -1 and this is +1, so these will cancel here. Okay, and you are left with AU only in the numerator. Okay, and A will cancel in numerator and denominator, so you will finally get U by 1 plus AU equal to V. So I am writing this relation here. So V will be equal to U divided by 1 plus AU. Okay, now you are to simplify this to find the relation. You are to simplify this to find the relation for 1 by V minus 1 by U. Okay, so we have made use of all these results which you have obtained in the previous lectures. So we can clear the space now, and we have now V, this is equal to, let me rearrange the terms, cross multiply this factor with U, V, so 1 plus AU, and this is equal to U. So you will get V plus AU, V, and then U. Now we will divide both sides by U and V, UV. So here you will get 1 by U plus A equal to 1 by V. You can rearrange it, 1 by V minus 1 by U, this is equal to A. Take this factor on right hand side and you will get this equation. Okay. Now if you compare this relation with the length formula, and the length formula is 1 by V minus 1 by U, this is equal to 1 by F. So from here you can justify that inverse of the focal length is equal to one of the element A of the system matrix. Okay, and 1 by F, inverse of the focal length, that gives you power. So this element A, it gives you power. Okay, now we will discuss little bit more the distances of the unit planes. We will determine du1 and du2, distance of first unit plane and second unit plane from the refracting surfaces. Okay, and we will discuss this later for thick lens. Okay, so we have calculated the value of du1. What we are doing? We are determining distances of unit planes from refracting surfaces S1 and S2. Okay, so we have obtained the relation for du1 and it was found to be 1 minus B by A and du2, this was C minus 1 by A. Okay. And what are ABC? ABC in case of the optical system which is thick lens in this case. So for that you have to keep in mind the system matrix for thick lens, system matrix for thick lens. This was 1 minus P2 into T divided by mu, and here you have minus P1 minus P2 plus P1 P2 into T, thickness of the lens, divided by refractive index, and here you have T by mu and 1 minus P1 into T by mu. Okay, so here this factor is minus A, this is B, this is C, and this factor is minus D, and you are to substitute the value of ABC here to get the value of du1 and du2. So firstly find the value of du1. So du1 will be equal to 1 minus B. Now see, this is B, so I am writing it here, 1 minus P2 into T by mu, okay, divided by A, and this factor is minus A. So you will write here P1 plus P2 minus P1 P2 divided by mu into T. Let me remind you again, this is minus A, so to put the value of A you have to adjust minus here. So I have adjusted minus here. Okay, now if you solve it, then you will get 1 minus 1, open the bracket. So minus 1 plus 1, these will cancel, minus minus it will become plus. So here you will get P2 into T divided by mu, and I am writing mu in denominator, and here you will write these factors same. So this is P1 plus P2 minus P1 P2 by mu into thickness of the lens. So this is the value of du1. In the same way you will find the value of du2 from there. So you have to keep in mind that we have obtained 1 by f, this is 1 by v minus 1 by u, and this is found to be equal to A. Okay, so basically you can see we will conclude all these things later. Okay, firstly find du2. So du2, this is C minus 1. So A, B, C, this is C. So C is 1 minus P1 into T by mu, C minus 1. So here you have minus 1, and you are to divide it by A, and the A is again P1 P2 minus P1 P2 by mu into T. Okay, if you open the bracket, then you see plus 1 minus 1, these will cancel, and you are left with minus of P1 into T divided by, you will adjust mu here, and you will write the denominator same here. Okay, so you have calculated the value of du1 and du2. Okay class, now you can take it a special case, you can do a special case. So class, now we can do this as a special case, and the special case here will be special case here is if the curvature radius of curvature of the both surfaces that is same. I want to say that R1 is equal to R2. Okay, R1 is equal to R2. Let take it R. In that case, the power of the refracting surfaces that will be same. Let us take it P. So if you substitute the value of P1 and P2 as P in this special case, then you will get dU1. I am writing it directly. This will be P. This will be P will cancel and you will get T by 2 T by, you see here, you can take P common. Okay, so here you are left with U refractive index and then you will get P plus P 2 P you have taken common, which will get cancelled with the P in numerator, and here you are left with 1P, okay, and then T and T by mu. Okay, and if you substitute the value of P, that is power, and the power is written like mu minus 1 divided by R. Okay, you can put the value of power here. Okay, and in the same way you can find the value of dU2. So from here you see, if you put the value of P1 and P2 as P, then you can solve it from here and it will be minus T, and here the factor will be same as you get in case of dU1. So now you are to see that this is positive and this one is negative. It means that if this is the thick lens and these are surfaces S1 and S2 and this is your optical axis, this is positive. It means it will lie here. It will lie here at a distance of dU1 from the first refracting surface, and this is negative, mean to say this distance is measured from S2, so the second unit plane will lie at a distance of dU2 from here. Okay, so this is the meaning of this thing. Now we are to find this focal length, this power which is given by A, and you have seen that in the here that this element is minus A. So if you find the value of 1 by F from there, this will be equal to P1 plus P2 minus P1 P2 into T by mu. Okay, so this is the relation, and you can put the value of P1 and P2. The value of P1 will be the value of P1 is mu minus 1 in this case, because the lens is placed in the air medium and the radius of curvature of the first refracting surface, and the value of P2 will be minus of mu minus 1 divided by R2. Okay, so after putting these values you can find the relation for 1 by F, that is the power of thick lens. Okay, so if you solve this, then you will get 1 by F. This will be equal to, put the value of P1, this is P1 and this is P2. So you can see this is, here is minus, so if you take mu minus 1 common, then you will get mu minus 1 here, and here you will get R1 minus 1 by R1 minus 1 by R2, and then minus, you are to multiply these two factors, so you will get mu minus 1 square, and here is minus, so minus will be plus, so here will be a positive sign, and you will get mu minus 1 square divided by R1 R2, and then you have T by mu, so here you will get T by mu. So this will be the final result. Thank Thanks for watching the lecture. Okay class, one more thing we have left is, if the thickness is very large as compared to the radius of curvature, then this factor will get cancelled out as compared to, because this will you can neglect this factor and you are left with d nu1 equal to t by 2 mu. In the same way, here you will get d u2 equal to minus t by 2u, and this will be the case when t is large. T is small. So keep in mind, if t is small and r is large, because if you put the value of power here is power and this is power, mu minus 1 by r. So if t is very small as compared to radius of curvature, so you can neglect this factor and you are left with t by 2 mu. Okay, and here minus t by 2 mu. One more thing, here you have t. If you are to find the relation of thin lens formula, then you can apply limit here, t tends to 0, then this factor will become equal to 0, or you can neglect it. Okay, and you are left with this relation, which is the power of thin lens. Thanks for watching the lecture. Again.